Okay, so here we have pretty much the same type of problem that we had in the last video, but I've just tweaked it a little bit so that we're dealing with short and tall plants instead of plant color, so it's very easy to see what's the dominant and recessive allele because we're using T's instead of P's. What I'm going to do in this video is I'm going to show you how to solve this problem, but actually using a Punnett square instead of multiplication. So what we have is, what is the probability of a short offspring, little t, when two heterozygous tall plants, big T, little t, breed? So first thing we see is that our parent generation are both heterozygotes. So we're having a big T crossing with a big T little t. From there, I can set up my Punnett square. All you need is you need to split off to 4 quadrants and split off an area where you can put your two different parents. So I'm going to put one parent on the top and one parent on the sides. I'm only going to write one allele in each column or row. The reason that I'm doing that is that I want to represent the separation of the gametes randomly distributing into, or of the alleles randomly distributing into the gametes. And only one allele is ever going to get passed on to each child. So I only want one allele from each parent. And then all I have to do is I need to fill in my Punnett square. So I'm going to bring my first big T down into both of the rows underneath it. I'm going to do the same thing with my little t. So that's the contributions that the parent on top can make. Then I'm going to do the same thing with the parent across the sides. I'm going to bring one across and one over to the far side. Now, here I have a big T pairing with a little t. When we write a heterozygous genotype, we always put the big allele first because it doesn't matter which order they actually get received in. Same thing here. I'm going to put the little t second because it's the same genotype no matter which parent contributed to the recessive and the dominant. And I'm going to bring my other one across as well. Okay. Then I have all of my children figured out now. I need to look how many of them are little t compared to the total. And I see I only have one little t, which is in this quadrant here. So that is 1 out of 4, which is equal to 0.25. And I would want to write this as 0.25 because if I look at my original question, it asked for probability. And the probability is always going to be between 0 and 1. Now, if I wanted to write this a different way, I already actually have the fraction because that's the division I used to figure it out. I could also multiply this by 100%. That gives us our 25%. Or I could write it as 1 little t, or 1 short to 3 tall. And remember, when you do the ratio, you're not doing it out of the total. You're doing it of how many variations there exist. So we have to have our ratio all add up to our denominator in our fraction, which is 4, and 1 plus 3 is equal to 4.